Hello, and welcome to Math Matters. I'm Miss Ogden, and today we're going to solve multi-step problems that involve finding the area of circles and squares. For this lesson, you will need paper and a pencil, or something else to write with. A scientific calculator that has pi would also be helpful, but it isn't necessary. We'll pause for about 30 seconds while you gather those materials. Now that you're ready, let's get started. Read the learning target on your screen as I read it aloud. I can solve multi-step problems involving area of circles and squares. We're going to dig into a real-world problem today where we'll have to find the area of a circle and the area of a square to solve it. Take a look at figures A and B on your screen. Would you rather have a slice from the chocolate cake in figure A or a slice from the vanilla sprinkled cake in figure B? Both cakes have the same height. Take a moment to jot down your thinking about why you'd rather have a slice from one of those cakes over the other. You might have noticed that the chocolate cake in figure A is smaller than the vanilla sprinkled cake in figure B. The radius in figure A is 4 inches. That means its diameter is 8 inches because we know that the diameter of a circle is twice as long as its radius. The vanilla sprinkled cake in figure B has a diameter of 10 inches. That means that figure A is a smaller cake than figure B. Maybe you already noticed that figure A is the smaller cake, but you still chose it because you just love chocolate cake. Or maybe you decided you'd rather have figure B because you don't really like chocolate cake. Or you just don't care what kind of cake you eat as long as it's got sprinkles. Maybe you have a completely different reason for choosing one of the cakes, and that's fine too. Mathematicians know that there are problems to be solved all around us. Let's take a look at Carlos's pizza problem. Read the problem on your screen as I read it aloud. Carlos is making a pizza. He is going to put it on a square baking sheet. What is the largest circular pizza that Carlos can make that will fit on his baking sheet? Let's think about what information we'll need to be able to figure out the largest possible circular pizza that Carlos will be able to make on his square pan. I know that if we're thinking about how much of the baking sheet the pizza will cover, we're going to need to find the area of the pizza. And the formula for finding the area of a circle is area equals pi times the radius squared, or pi r squared. It looks like we're going to need to find the radius to find the area of this circle. We can see the dimensions of Carlos's pan based on the picture, and since it's a square, we know that every side is 12 inches long. That means that Carlos can fit a circular pizza with a diameter of 12 inches on his baking sheet. Now that we've figured out the diameter of the pizza, we can use that to help us determine the radius. We know that the radius of a circle is half the length of its diameter. So, if the diameter is 12 inches, the radius must be 6 inches. Now that we know that the radius is 6 inches, we have enough information to figure out the area of Carlos's pizza. All we have to do is substitute the value of the radius from Carlos's pizza into the formula. Go ahead and take a moment to find the area of Carlos's pizza. Feel free to use your calculator to find the area if you have one. If not, think about how mathematicians might use estimation to help find the area. If I were going to solve this problem using estimation, I'd probably round pi to 3, then multiply 3 times 6 squared, or 3 times 36. My estimate for Carlos's pizza is 108 inches squared. My hunch is that the exact area of Carlos's pizza will be a little more than 108 because 3 is a little less than the value of pi, which is about 3 14/100. Mathematicians make estimates all the time to check if their answers are reasonable. We'll come back to our estimate a little later to see how it compares to our exact answer. To find the exact area of Carlos's pizza, we'd need to multiply the value of pi, 3 14/100, by 6 squared, or 36. The exact area of Carlos's pizza is 113 inches squared. Now let's revisit our estimate to see how it compares. Our estimate was 108 inches squared, and the exact answer was 113 inches squared. We can see that our estimate is pretty close to the exact answer. It's just a little lower. Mathematicians use estimation as a tool to check for reasonability in their answers. Now let's think about how much of the baking sheet the pizza does not cover. To figure this out, we're going to need to find the area of the entire baking sheet. Once we know the area of the baking sheet and the pizza, we'll be able to figure out how much of the baking sheet the pizza does not cover. We can use the picture to help us figure out the area of the baking sheet. The picture shows us that one side of the baking sheet is 12 inches long. And since it's shaped like a square, we know that all of the sides are congruent, or the same, so every side is 12 inches long. Now we have enough information to find the area of the square baking sheet, because the formula for finding the area of a square is length times height, or A equals side squared. Go ahead and take a moment to solve for the area of the square baking sheet. When we square the length of one side of the baking sheet, we find that the area is 144 square inches. Now that we know the area of the square baking sheet and the area of the pizza, we have enough information to solve the problem. The square baking sheet is 144 square inches, and the pizza covers 113 of those square inches. That means that 31 square inches must not be covered by the pizza. We can prove this by subtracting the area of the pizza from the area of the square baking sheet. That will leave us with how much of the baking sheet is not covered by Carlos's pizza. I think you're probably ready to solve a problem on your own. Take some time to find the area of the purple square that is not covered by the circle. Feel free to use estimation or your calculator as a tool to help you solve this problem. We'll pause for about 1.5 minutes for you to solve the problem. Let's take a look at the answer. First, let's see what the area of the entire square is. Next, here's the area of the circle. Finally, we can subtract the area of the circle from the area of the square to find the area of the square that is not covered by the circle. In today's episode of Math Matters, we solved a real-world multi-step problem involving the area of both a circle and a square. I challenge you to find the area of different square and circular objects at your home. Give it a try and share anything that you might find with your teacher. We'd love to see what you come up with. I'm Miss Ogden. I hope you have a great day and keep on counting.